Hello and welcome back to Engineers Olympiad. We are doing the numerical questions for the topic weight volume relationships in geotechnical engineering. This is the video lecture number 2 for the same series and the same topic. Video lecture number 1 is already uploaded on this channel. You can watch that video before watching this video. So let's get started. Question is 1 cume of wet soil weighs 20 kilonewtons. Its dry unit weight is 18 kilonewtons. Specific gravity of solids is 2.67. We have to determine the water content, the porosity, void ratio, and the degree of saturation. We have to draw phase diagram also. So we'll be drawing the phase diagram for this question as well. All right. So let's get started and solve this question. We'll be making a phase diagram first. Let me make a phase diagram first. All right. So this is the air phase. This is water. And this is the soil solids. This is the phase diagram. Air, water, soil solids. All right. We'll be writing weight from this side and volume from this side. All right. Let's see what question has given us. 1 cume of wet soil weighs 20 kilonewtons. 1 cume. That means volume is 1 cume. All right. This is the volume. It's also given 1 cume of wet soil weighs 20 kilonewtons. Weight is 20 kilonewtons. This is how we go on making phase diagrams. 20 kilonewtons. Once our phase diagram will be done, then it's quite easy to solve this question. All right. So first we have to make the phase diagram. So volume is 1 cume or 1 cubic meter, and the weight is 20 kilonewtons. All right. Its dry unit weight is 18 kilonewton. Dry unit weight, what does that mean? That means the weight of the soil solids is 18 kilonewtons. All right. Dry unit weight is when all this water phase is gone, air phase is gone. We're only left with the soil solids phase. That means the dry unit weight is 18 kilonewton. Will represent the same on the phase diagram. From the weight side, that means this much is, though this diagram has not been made to the scale, that must also be known. This diagram is not made to scale, that's why this may seem quite unproportional. So this is the dry unit weight, which is 18 kilonewton. That means the weight of the soil solids is 18 kilonewton. All right. What else? All right. So we have to now solve this question. So we have made a phase diagram based on the data given in the question. We'll be solving this question stepwise, and please keep on watching. All right. Weight of water. The total weight of the wet soil is 20 kilonewtons, out of which dry soil weighs 18 kilonewtons. That means weight of water is total weight minus weight of soil solids, right? Which indicates weight of water is total weight 20 kilonewtons. Weight of soil solids or dry unit weight 18 kilonewtons. That means weight of water is 2 kilonewton. All right. After that, we'll be finding volume of solids. Volume of solids will be given by this equation: weight of solids divided by specific gravity multiplied by the density of the water. All right, we found the weight of the water. Now we'll find the volume of the solids. All right, for that, weight of the soil solids is 18 kilonewton because it's given in the question that the dry unit weight is 18 kilonewton. Specific gravity of soil solids. How much is that given in the question? Note carefully, it's written clearly over here that specific gravity of solids, that means the soil solids, is 2.67. We'll be substituting the same value here in the equation. 2.67. 2.67. All right. So 2.67 multiplied by the density of water. We know that the density of water is 10 kilonewton per cubic meter. This is the density of the water. All right. So I have written it over here. So after substituting the value, which is equal to 10 kilonewton per cubic meter, I'll be finding the volume of solids. Volume of solids by calculation, it is 0.674 cubic meter. So volume of solids is 0.674 cubic meter. How did we arrive at this? Because we knew the weight of water. So we use the equation volume of solids is equal to weight of solids divided by specific gravity of the solids, which was clearly given in the question, multiplied by the density of the water that we know at 4 degrees centigrade. All right. So volume of solids came equivalent to 0.674 cubic meter. Now we'll represent the same on the phase diagram. Volume of solids, how much? 0.674 0.674 cubic meter. All right, we have represented the same thing onto the phase diagram. Moving on, we'll be finding now, we have the total volume. How much? 1 cubic meter. We found the volume of the solids. How much? 0.674 cubic meter. All right, now we'll be finding the volume of water. Volume of water is equal to weight of water divided by density of water. We know the weight of the water. How much? We calculated this in the very beginning. Weight of the water was equal to the total weight, which was 20 kilonewton, the weight of the wet soil minus the dry unit weight, that is the weight of the soil solids, which was 18 kilonewtons, right? So weight of water is 2 kilonewtons. So 2 divided by density of water, 10 kilonewton per cubic meter. All right. So volume of water. How much? By calculations, it is 0.20 cubic meter. All right. It is 0.20 cubic meter. So now I have volume of water as well. I'll be representing the same thing onto my phase diagram. Over here, this is the volume of water, and by calculations it came equivalent to 0.20 cubic meter. All right, after that we know the volume of solids, we know the total volume, and we know the volume of water as well. We'll be finding the volume of voids. Volume of voids is total volume minus volume of solids, because volume of voids is the combined volume of air phase and the water phase. So we'll be subtracting the volume of soil solids from the total volume. Then we'll be having our volume of voids in this soil phase system. So volume of voids is equal to total volume is 1 cubic meter minus volume of soil solids, which we just found out it was 0.674 cubic meter. So by calculations, volume of voids is 0.326 cubic meter. All right, this is how we arrive at the volume of voids by finding the volume of solids. So volume of voids is 0.326 cubic meters. All right, moving on, we'll find, let me write over here, water content, what the question demands. See, we have to determine the water content, the porosity, void ratio, degree of saturation. So we have to find the four different things: water content, porosity, void ratio, and degree of saturation. So the first goal is to find the water content. Water content, as we know, water content is equal to weight of water divided by weight of solids. And all we have the values of both of them. So weight of water, it is weight of the water content is weight of water. Weight of water is how much? 2 kilonewtons. We found this at the very beginning. So 2 divided by weight of solids, that is itself given in the question, that the dry unit weight is 18 kilonewtons. That means weight of soil solids is 18. By calculation, my water content is 11.1%. 11, we always report water content in terms of percentage, and it came equivalent to 11.1%. So the first thing that question demanded, we have found the water content and it came equivalent to how much? 11.1%. Next thing that question asks us is to find the porosity. All right, porosity. Porosity, as you know, it is represented by this, and it's the ratio between volume of voids to the total volume. So the porosity is volume of voids that we just found out. It is 0.326 divided by total volume, that is 1 cubic meter. By calculations, porosity is equal to, we also report porosity just like water content in terms of percentage, and by calculations it is equal to 32.6%. All right, the next thing, second part is also covered. We have found the water content, we did find the porosity. Next thing that we have to find is the void ratio. Let's go on finding the void ratio. We can easily use the relationship between porosity and the void ratio, and we will be finding a void ratio. Void ratio, as you know, it's denoted by E, and it's a ratio. All right, and since we have the value of porosity, we just find it. Now we'll be using the relationship which relates porosity and the void ratio, and we'll be arriving at our void ratio. That is the next thing that question demands us to find. We know the relation is n divided by 1 minus n. All right, this is the relationship between the porosity and the void ratio. Void ratio, as we know, it is volume of voids divided by volume of solids. So by calculations, my void ratio is E is equal to N, that is 0.326 divided by 1 minus 0.326. By calculations, it is 0.48. We can also find our void ratio by this thing, because we know both of them, volume of voids, volume of solids. How much is the volume of voids? 0.326. How much is the volume of solids? Volume of solids, 0.674. 0.674. By calculations, this is also equal to 0.48. So we have two different ways by which we can find void ratio in this question, because we just find the value of this porosity. We also have the values of volume of voids and the volume of solids. So we can use either of the equations, and we arrived at the void ratio, which the question demanded us to find. So by calculations, it was equal to 0.48 is the void ratio of this soil phase system. All right. Now the last part of this question, that question asks us to find, we did find the water content, porosity, void ratio. Now the only thing that remains is the degree of saturation. And it's quite easy to find degree of saturation because we know all the terms that are required to find it. Let me rub it first. We have a little less space over here. All right. This is the last part that I'll be finding to find the degree of the saturation. And we know degree of the saturation, we have a general equation. ES is equal to WG. We'll be using the same because we have all the three values, and we'll be finding our degree of saturation for the soil phase system. All right. Degree of saturation. Degree of saturation is given by, we know that ES is equal to WG. That means S is equal to WG divided by E. We know water content. That was the first thing we found. And it was equivalent to how much? 11.1%. We'll be substituting the values, water content. All right. All right. Water content 11.1%. Specific gravity of soil solids given in the question 2.67 over here. 2.67. Void ratio we just found using two different equations 0.48. By calculations, my degree of saturation is 61.74%. All right. So we have completed this question wholly and completely. We have found all the four different parameters that question demanded us to find. We found the water content, which was 11.1%. Then we found the porosity, which we also report in terms of percentage, and it was equal to 32.6%. Then we found the void ratio 0.48, and after degree of saturation 61.74%. All right. So this is how we go on drawing phase diagrams, where when we use a block diagram and we place weight on the right side and the volume on the left side, and we go on describing certain parameters in terms of weight as well as volume. All right. Volume of air phase, volume of water, or the volume of soil solids. And also we have this thing, that is, we go on representing the weights from the right hand side. It was given that the weight of the wet soil was 20 kilonewtons. I have represented it here. And then it was also given that the weight of the dry soil is 18 kilonewtons, which I also depicted in this phase diagram, which was not drawn to any scale. This was just a mere representation of the situation happening in this three-phase soil system. And we found the weight of water as 2 kilonewton, which I forgot to present over here in this phase diagram. All right, so it was weight of water, and it was equal to 2 kilonewton. All right, so that's how we solve this question. Moving on to the next one. All right, the question is, during a test for water content determination on a soil sample by picnometer, the following observations were recorded. Mass of wet soil sample was 1000 grams. Mass of picnometer with soil and filled with water is 2000 grams. Mass of picnometer filled with water only is 1480 grams. Specific gravity of solids is 2.67. We have to determine the water content. If the bulk density of the soil is 2.05 grams per milliliter, determine the degree of saturation. So the first part of the question is to determine the water content, and we have been given certain values for water content determination on a soil sample by picnometer, and we have to find the water content. And subsequently, it is also given in the question that if the bulk density of the soil is 2.05 grams per milliliter, we have to go on finding the degree of saturation as well. All right, so let's do this question. This is a typical question for the determination of water content by a picnometer. All right, picnometer, as you know, picnometer is a glass jar of about 1 liter capacity and fitted with a brass conical cap by means of a screw type cover, and this cap has a small hole of about 6 mm diameter at its very apex. Or also we can use the same picnometer for finding out the specific gravity, but it is to be noted that when we use the picnometer method for the determination of water content, the specific gravity of soil solid particles must be known to us, and it is given in the question that the specific gravity of soil solids is 2.67. All right, so we'll be solving this question first. All right, the general equation, or the general formula by which we find the water content, we go on determining the water content by using the picnometer, is water content is given by M2 minus M1 divided by M3 minus M4 multiplied by G minus 1 divided by G minus 1 into 100. This is the generalized formula by which we go on determining the water content by the picnometer. All right, the only thing that must be known to us is the specific gravity, which is known to us. It is given in the question. It is 2.67 is the specific gravity of the soil solid particles. All right, now we have to know what is this M2, M1, M3 and M4. Let me tell you. In picnometer method for determination of water content, M1 is mass of picnometer, wherein I just told you that the picnometer is a glass jar of about 1 liter capacity and fitted with a brass conical cap by means of a screw type cover, and it usually has a small hole of about 6 mm diameter at its apex. So M1 is the mass of picnometer. M2, mass of picnometer plus wet soil. Mass of picnometer plus wet soil. M3. M3 is mass of picnometer plus wet soil plus water. Mass of picnometer plus wet soil plus water. M4 is the mass of picnometer filled with water only. M4 is the mass of picnometer M4 is the mass of picnometer filled with water only. Filled with water only. So we'll see what data has been provided in the question, and we'll go on substituting the values in the general formula, and we'll be having the water content of the soil system. All right, so let's see. All right, mass of wet soil sample, it is given as 1000 grams. All right, then we have been given mass of picnometer with soil and filled with water 2000 grams. mass of picnometer filled with water only 1480 grams. All right, and then we have been given specific gravity as well. We have to go on and we have to find the water content. All right, because the question is typically based on the water content determination by using a picnometer. All right, so let's go on solving this question. Water content M2 minus M1. M2 is mass of picnometer. I would have been directly substituting the values, but I had to show you students something over here. Mass of picnometer plus wet soil is M2. We have to subtract mass of picnometer from this. All right, mass of picnometer, this is the M2 thing. All right, minus M1. But in this question, we have not been given the mass of picnometer, but rather we have been given the mass of wet soil sample as 1000 grams. Please note carefully, we have not been provided the mass of the empty picnometer, rather we have been given the mass of the wet soil sample as 1000 grams. All right, so in this term, this thing M2 minus M1, this and this will go. We're only left with mass of wet soil sample, so I'll be just substituting 1000 grams here in this numerator. All right, the data as provided by the question didn't have the mass of picnometer or the empty picnometer. It rather has given us the mass of the wet soil sample. If I'll be going on substituting the M2 minus M1, M2 is mass of picnometer plus wet soil. I have to subtract M1, that is mass of picnometer, from this. So this and this will go, will are left with this thing, mass of wet soil sample, which is very well given in the question as 1000 grams. So I'll be substituting the same value. So let me show you. W M2 minus M1, mass of wet soil sample 1000 grams, divided by M3 minus M4. M3 is mass of picnometer plus wet soil plus water. That is very well given in the question. How much? 2000. Mass of picnometer with soil and filled with water. So our M3 is 2000 minus M4. What is M4? Mass of picnometer filled with water only. That's also given in the question. Mass of picnometer filled with water only is 1480 grams. So I'll be substituting the value 1480 over here. All right. Then what is the general equation? G minus 1 divided by G. G is given. How much is G? 2.67 minus 1 divided by 2.67. Once again, I'm telling you, it's quite impossible to determine the water content of a given soil sample without knowing, by the picnometer method, without knowing the specific gravity of the soil solids. We must be knowing this item, then only we can be finding the water content by the picnometer method for any given soil sample. All right. Then in generalized equation, minus 1 multiplied by 100. All right. So I used all the complete data as was given in the question, and I substituted the values in the general formula as has been formulated for determining the water content by the picnometer method of any given soil sample. The only parameter that must be known to us is the specific gravity of the soil solid particles that has been given in the question. All right. By calculation, water content is equal to 20.28%. So we have completed the part 1 of the question. Next thing that question asks us to find is if the bulk density of the soil is 2.05 grams per milliliter, determine the degree of saturation. All right. We know the equation dry density is bulk density divided by 1 plus water content. All right. We know this. So dry density is bulk density. How much? if the bulk density of the soil is 2.05 grams per milliliter. 2.05 grams per milliliter divided by 1 plus water content. We have it. We just found the value of the water content. It is 0.2028. By calculation, dry density is 1.70 grams per milliliter. Our goal and aim is to find the degree of the saturation. Determine the degree of the saturation. Alright. We also know dry density is equal to G rho W 1 plus E. Actually, I'm doing this whole thing just to find out this thing, white ratio. Then subsequently, we'll be using the equation ES is equal to WG, and the aim and the goal that we have to find, that is degree of the saturation, will be found out subsequently. Right? So I must be knowing E first. That's why I'm doing all this. So dry density we just found out 1.70, specific gravity 2.67, density of water is 1 gram per milliliter. Alright, density of water is 1 gram per milliliter. 1 divided by 1 plus E. By calculations, E is equal to, so E is equal to 0.57. So I just found out the white ratio. Now I can very easily find the degree of saturation because we know ES is equal to WG. S is equal to WG divided by E. S is water content. We actually had all the data from the picnometer method for the determination of water content of a given soil sample, and we actually found the water content by using the general formula, and it was equal to how much? 20.28%. So let me substitute the value over here, 20.28%. Specific gravity was very well given in the question itself. 2.67 is the specific gravity of the soil solid particles, and the white ratio, I did find it out as well. It is 0.57. And by calculations, my degree of saturation is 95%. So we have completed the question in all respects. We found the water content, and we also found the degree of the saturation if the bulk density of the soil was 2.05 grams per milliliter. Alright, moving on to the next one. Question is, in a compaction test on a soil, the mass of wet soil when compacted is in mold was found 1.855 kilograms. The water content of the soil was 16%. If the volume of the mold was 0.945 liters, determine the dry density, void ratio, degree of saturation, and percentage air voids. Take G as 2.68. Alright, so this is the question. So let's solve this. We have been given certain data that in a compaction test on a soil, the mass of wet soil when compacted in mold is this, the water content is this, volume is this. We'll be solving this question one by one. Bulk unit weight is mass per unit volume. Alright, how much is the mass? 1.855 kgs. How much is the volume? 0.945 liters. By calculation, my bulk density is 1962.96 kilogram per cubic meter. Alright, now I have the bulk density, I'll be finding the dry density. dry density. As you know, it's bulk density divided by 1 plus water content. This thing we know, 1962.96 kilograms per cubic meter divided by 1 plus water content. How much is the water content? The water content of the soil was 16%. All right. That means 0.16. This question is based on the data as given when we have done a compaction test on a soil sample and we have reported certain things, and subsequently question demands to find the dry density, void ratio, degree of saturation, and the percentage air voids. And we are solving this question one by one, step by step. So dry density by calculations is 1692.20 kilograms per cubic meter. All right, we have the bulk density, we have the dry density. We'll be using one more equation for the dry density, so that we'll be having another parameter, that is the void ratio. All right, so dry density 1692.20, specific gravity given in the question, take G 2.68. All right, density of the water, how much is it? 1000 kilograms. 1000 kilograms per cubic meter. Will be using the same in our question, 1 plus E. By calculations, my E is 0.58. When I have void ratio, I can be using the equation correlating porosity and the void ratio. So I'll be also arriving at the porosity. So porosity is E divided by 1 plus E. E is 0.58 divided by 1.58. By calculations, it is 36.70%. All right. Determine the dry density. We have found the value. Determine the void ratio. We have void ratio as 0.58. Determine the degree of saturation. So we have to find the degree of saturation. Degree of saturation, as you know, we have these 4 parameters related by this equation. ES is equal to WG. So S is equal to WG divided by E. W is how much? Water content is given in the question as 16%. 0.16. Take G as 2.68. Written in the question, 2.68. And the void ratio, we just find the value of it as well. 0.58. All right. So degree of saturation is 0.16 multiplied by 2.68 divided by 0.58. So by calculations, degree of saturation 73.93%. All right. Looks a little weird. Oh, again. So degree of saturation is 73.93%. All right, so I think we have completed all the parts. Dry density done, void ratio done, degree of saturation done. All right, the last thing that remains is percentage air voids. All right, so question also demands to find the percentage air voids. Percentage air voids as you know, it is a ratio between volume of air to the total volume. Percentage air voids is a ratio, it's denoted by NA, and it is equal to, it is a ratio between volume of air to the total volume. All right, now see how smartly we have to find this. We know that void ratio, it is volume of voids to the volume of solids. We know porosity, volume of voids divided by total volume. Now we also know this thing, dry density. We have one equation wherein air content is incorporated, and I'll be showing you that expression for the dry density, that is 1 minus Na G rho W divided by 1 plus Wg. See how I'll be substituting the values. Dry density is equal to, dry density we found out. How much was the value? Dry density is 1692.20 kilograms per cubic meter. 1692.20 kilogram per cubic meter. 1 minus percentage air voids as it is, G 2.68, density of water 1000 kilograms per cubic meter, divided by 1 plus water content is 16%, and specific gravity is 2.68. By calculations, 1 minus this thing, percentage air voids, it is 0.9021. So percentage air voids is 9.79%. Percentage air voids, which is a ratio between volume of air to the total volume, by calculations it is equal to how much? 9.79%. So we completed the question completely. We did find all of the values. Dry density, void ratio, degree of saturation, and percentage air voids. Percentage air voids came equivalent to how much? 9.79%. This was a typical question of weight-volume relationships, and the data was as per a compaction test that was conducted on a soil sample. All right, very interesting. Let's move on to the next one. All right,